This is part 3 of Ninja Jumper made with Pygame 0 on Mu. Okay, so far we've got the ninja on the screen and the platform. So now we want to obviously make the ninja move about and interact with the platforms and obviously fall down with gravity. Now the very first thing I'm going to do is I'm going to make a new function. So I'm going to scroll right down to the bottom, and just above where I've got the background color fade, I'm going to add in a new function, and I'm going to call it collide check. Bracket colon. So this is going to be a function which checks whether the ninja is in contact with any of those platforms or the ground. So I'm just going to make up a new Boolean variable called false. Okay, so that's going to be whether we're colliding with something. Now, using a loop, I'm going to go through the list that we've got at the top of the page. This list here, platforms. I'm going to go through this list and I'm going to check whether we're colliding. So for I in platforms, okay, I'm going to say if ninja dot collide rect, so if any of the rectangles of the images collide, then I'm just going to set collide to true, and then return, let's get in the right place, return collide. Okay, so it's going to be returning false if it's not colliding, and it's going to be returning true if there is a collision. Okay, so next step, we need to add in some new variables that we're going to be using with the ninja. Okay, so in terms of its left-right movement, we're going to make up a new variable called ninja x velocity. Okay, and just start that off at 0. Okay, and then we're going to have another one, ninja y velocity. So up and down velocity is going to be started off at 0 as well. And then we're going to have obviously something which pulls him down. I'm just going to call that gravity. It's not going to behave exactly the same as gravity. It's just imitating gravity. But we're just going to start that off at 1. And then we're going to say jumping equals false. Okay, so you'll see how that's used in a little bit. So now we're going to go and make the function which moves this ninja. Okay, so I'm going to start a function and call it def ninja move, ninja underscore move. Okay, and obviously if we're creating a function, we want to run that function. So I'm going to run that function all the time inside the update. So I'm going to say ninja move. Okay, I'm not going to run the collision function in there because I only want to run that sometimes. So I'm going to leave that out of that update function for now. So inside the ninja movement function, straight away we're going to globalize a load of variables. All those variables we just created basically. So it's ninja x velocity, ninja y velocity, and it's going to be jumping and gravity. Okay, so those are the variables we just created. Okay, so now let's add in some gravity. Okay, so this is going to be what pulls the ninja down. Okay, so I'm going to say if not collide check. Okay, so it's going to go and check that. It's going to run that function. It's going to check whether we're colliding with anything. If we're not, then we're going to move the ninja down. So ninja.y plus equals gravity. Okay, so if I was to run this function right now, the ninja would start falling. There we go. So it's falling on the screen very slowly, hits the platform and stops. Lovely. But that didn't look very realistic, did it? Just in real life, if you start falling slowly, and then you speed up. We're going to imitate that. So I'm going to say if gravity is less than or equal to 20, then gravity plus equals 0.5. Okay, so then there we go. So we fell down a little bit through the platform, but that's something we're going to have to deal with. And there we go. So it looks a bit more realistic. So that's good with the gravity, but what we need to do is we need to reset that gravity, because as the game plays, the gravity is going to stay on 20 at the moment. It's not going to reset. So I'm actually going to add another bit more code above this, and I'm going to say if collide check. Okay, so this is if collide check is true. We're going to set gravity back to 1. Okay, and then we're actually going to move Ninja up just a tiny little bit, minus equals 1. Okay, now the reason we're doing this, okay, is because using this loop function where we're checking in a loop whether we collided with the platform, sometimes the Ninja goes through the platform, as we saw. Quite often, in fact, it goes through the platform. And this brings our Ninja back up to the top of the platform. Just with this method, there's no way around going through the platform. It will go through the platform ever so slightly, but adding in this code, this line of code here, it will bring the Ninja back up to the top, and then we're obviously resetting gravity. Okay? You will notice, though, that at the moment the Ninja is behind the platform, which does look a little bit silly sometimes. So what I'm going to do is I'm going to go up here, I'm going to grab this ninja.draw, and I'm going to place it after we've drawn the platforms. The order here obviously is important. And so now the Ninja will be in front of the platform. There you go. It's a very slight difference, but it is noticeable. And now obviously the gravity is working well. You might also be wondering why I'm not doing if and then else, okay? Because I could write in else in here, okay? I could write else, whoops, get that right, else, and then do that bit there. And it looks like it's exactly the same, but look what happens in the game. We get a tiny little bit of stutter in the Ninja going up and down, which I don't like, and I've discovered that if you do it in separate functions, you don't get that little stutter, and then he stands nice and perfectly still. So there you go. So that's gravity. Right, moving on. Now we're going to have a go at the left and right movement. Okay, so if keyboard.left, okay, obviously to move the Ninja right is easy. We say ninja dot x, ninja underscore, get that right, ninja underscore x velocity minus equals 2, because that makes the Ninja go left. And then after we've done our controls for our left and right, what we would do is we'd say ninja.x plus equals ninja.x velocity. So, and then obviously you could do exactly the same for right as well. And then we go right, but that's going to be plus equals 2. So let's just demonstrate that and see what's wrong about that. So Ninja's great, left, okay, so he moved left, but he flew straight off the screen. Right, okay, so I can turn around, but and he goes flying off the edge of the screen, and he's also goes incredibly fast, and he just goes flying off the edge of the screen. So it's not perfect. We need to do a few more things. To stop him going off the edge of the screen, we need to put in some code. I'm going to put it beneath this block of code just down here. I'll explain why in a moment, in a while. So I'm going to say ninja, if ninja.x is less than 50 or ninja.x is greater than 950, we're just going to set ninja.x velocity to 0. Okay, so that when we run that, he'll stop at the end. Okay, but there's a problem there. Even though he stops at the edge of the screen, okay, by holding down the key, you can actually push past the edge of the screen. So the user could push the player off the edge of the screen, which we don't like. And also, as you can see, the Ninja can end up going very fast if you hold down the key like unnaturally fast. You might want that in your game, but for my game, I didn't want that. Okay, so let's make this better. So after I press the left key, I'm going to add in another if, just to add in some other conditions. So I'm going to say if ninja.x is greater than 40 and ninja.x velocity is greater than -8, okay, then we allow the ninja to move. And very similar with moving right, we say if ninja x, just make that look a bit neater, if ninja x this time is less than 960, so these are the edges of the screen, and ninja velocity less than 8. So it's only allowing movement if we're in the not right at the edge of the screen, as in 40 pixels off the edge of the screen, and if we're not going faster than 8 speed, then it allows movement. So by doing that, in combination with that code down here, we'll prevent the character from going off the edge of the screen, and it also prevents it going too fast. I've made a little mistake. I forgot. What did I forget? Unexpected indent block line 66. Yes, should have tabbed that in. Okay. So now, okay, there we go. So he doesn't go too fast now. He still goes quite fast, but not super fast. And he stops at the edge of the screen, and I can't push the ninja off the edge of the screen. Okay. So now I'm going to explain why I placed this code after the movement here. Just show you quickly, if I was to put this up here, I found that the ninja gets stuck at the edge of the screen and he can't move. He's stuck there now. Left, right doesn't work. He's stuck. So just by putting the code after, that works much better. And then also with the velocity, I'm trying to imitate real life where as you're running, if you stop running, you don't stop immediately. You slow down ever so slightly. At the moment, the ninja just keeps going, doesn't he? He just keeps going non-stop. If I let go of the key, he just flies along. That's very unrealistic. So what I'm going to do is now do some changing to the velocity. So I'm now going to say if ninja underscore x velocity is greater than 0, I'm going to set ninja x velocity minus equals 1. So it's if we're moving in that direction, it's going to constantly be slowing down. Okay, I'll do another if, and then, but the other way around, if ninja velocity is is less than 0, then we're going to increase it by 1. Now realize here I'm not doing elifs, I'm always doing ifs, and that's just because it means the code runs more quickly and it runs more efficiently as well in Pygame. That wouldn't be the case in maybe when you're programming other things, but in Pygame it definitely works better this way. So there we go. So now, okay, so as I let go of the left and the right key, the ninja does slow down somewhat, but he doesn't slow down immediately. He comes to a gradual stop, okay? And also when I get to the edges of the screen, he comes to a standstill, but doesn't go off the edge of the screen, and you can move again out from the edge of the screen. So there we go. So there is falling and left and right movement. Okay, so go and give that a go.